So in this video, we're going to talk about more how you would do this if you had a really complicated molecule. Now this is far outside the scope of anything you cover in Chemistry 1, so this is kind of for those who are interested in knowing this type of information. Now in the previous videos, I told you that you can identify what's in the backbone by identifying the functional groups. And if we look at this, there are 4 functional groups. We have a CH3, a CH, a CH, and a COOH. Now, to take organic chemistry, what you're going to learn is that a COOH group looks like this. So it is a carbon connected to whatever the next atom is in the chain. The COO is your carboxylic acid group. Now, knowing this, you've got a chain with 4 carbons plus that oxygen. So we've got carbon, 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 and this carboxylic acid functional group. Now, around each of these functional groups, we've got 3 hydrogens around the CH3, this methyl group, and an H, and an H. So how do we draw this? Well, one is to put the valence electrons around them, connect the dots. The other is to do an accounting. But there's some rules of thumb we can do to kind of short circuit a lot of this. There are things that are always true for organic chemistry that may not be true if you're getting outside of organic chemistry. The first is that carbon always has 4 bonds around it. So we're going to basically connect it to periphery atoms, and then we're going to start adding bonds to carbon until we get up to 4. Now, why do I say this may not be true in the real world? If you go look at carbon monoxide, that's carbon sometimes with a double bond or triple bond, depending on how you draw it. Carbon doesn't have 4 bonds. There are exceptions to this, but typically, especially in organic chemistry, you're always dealing with 4 bonds around carbon. Oxygen always has 2 bonds. Nitrogen always has 3 bonds. And hydrogen and fluorine always have 1 bond. So as long as we have these numbers, it will always work out. Now the other thing about oxygen and nitrogen, 2 lone pairs on oxygen, 1 lone pair on nitrogen. And so you can see with this oxygen up here, 2 bonds, 2 lone pairs, 2 bonds, 2 lone pairs. So how do we draw this without having to work through all the accounting? Well, the easiest thing to do, we know they each have to be connected to the atoms around them. So if we look at this hydrogen, all the hydrogens, they each have 1 bond. So we satisfy this restraint. What about the carbons? Well, this has 4. 1, 2, 3, 4. This one only has 3. 1, 2, 3. So it's deficient in 1 bond. This bond is also, carbon is also deficient in 1 bond. This one has its 4, so it's satisfied. So it tells us that we need to draw 1 extra bond in here, and we're going to put it right here. So this would be how you would draw the Lewis structure for this particular material. In this case, these are more what you're satisfying. You're not actually going through and counting electrons. But again, this is kind of outside the scope of the course. This, if you go into organic chemistry, though, is going to be more what you become familiar with in terms of how to draw Lewis structures for long, complicated materials.